test explanation, lab, quiz, and some flashcards. So ISIS stands for Intermediate System to Intermediate System. The cool thing is it wasn't even made for IP. Back in the day, it was designed for the OSI stack to write something called CLNP. But instead of dying with OSI, it got extended for IPv4 and IPv6 on the TCP IP stack, and it's still used in massive service provider networks to this day. Now, why is it different from OSPF? OSPF packets ride inside IP. ISIS skips that and instead places its packets straight into a layer 2 frame. That makes it way more flexible. It can handle IPv4, IPv6, or any new protocols that come along. When ISIS routers talk to each other, instead of sending LSAs like OSPF, they send PDUs, which are called Protocol Data Units. And everything inside is built as type length values, or TLVs. That design makes ISIS super easy to extend, and it can support MPLS or segment routing with just a few more TLVs. Now, ISIS has two different levels. Level 1 is inside an area, kind of like a neighborhood, whereas level 2 is between areas, which is the backbone connecting neighborhoods together. And yes, a router can do both at the same time. How do routers know what area they're in? That's the job of the net address. Cisco defines it as Area System ID and NSEL. The area IDs must match for routers within the same area. The system ID, however, must be unique, and that is 6 bytes long. And the NSEL is always 00 for routing. Here's an example. The 49 is akin to RC 1918 for IPv4. The 0010 represents the area, and the middle block comprises of the unique router ID. Lastly, the two zeros at the end is the NSEL. The config is pretty simple, so initiating ISIS, setting a net value, configuring the IS type, and lastly, setting ISIS on an interface. There's also some show commands that are very easy. Show CLNS neighbors, show ISIS neighbors, which show similar information, and show ISIS rib. Moving on to the lab portion, you can see that these are actually all IOLs. I just decided to do that to make it faster. So let's define router ISIS, and let's put 1 as the ISO tag. From here, let's define the net ID as 11.1.4, as it suggests there. And now let's set the system ID. And there we go, let's put it to 1. And the IS type. This one has no L2 links, so we'll leave it as level 1. And let's configure ISIS on each of these interfaces. And since 0. Perfect, that'll do. Let's now go into L2 and do the same thing. 1 net 49, except that it's 11, so I default. So there we go, 132.0, and this time let's set it to L1-2 because it has a L2 link as well as an L1. Now let's go to each interface. And don't forget the loop back here. Now let's move on to R3, same sort of deal, except this time we're going to be changing the area here. So 22, 154, and 4, 1, 3, and there we go. And now let's see the IS type, same as L2, since L1 and L2 are in different areas. And on each interface. It'd probably be smarter for me to just paste everything, but I just want to show you guys what it's like. Do this all manually, and it's good practice too. That way, it's just ingrained inside you. So here, let's do 2, 2, 1, 4, 3, 4. Okay, perfect. Now let's set the IS type to level 1 and configure it on each interface. Perfect. Now let's confirm it worked. So show CLNS neighbor. Perfect. Let's do the same thing here. And let's make sure we have some routes in here. So what I didn't mention before is that L1 routes have a default route to their L2 gateway. So this is 20. It's basically R3s here. And now let's do the same thing here. So we expect to have 1.1.1 here, 2.2.2, so everybody is inside the L2 database. And similarly, we can see for R2 as well. So do show CNS neighbors, do show ISIS neighbors, and we can also see that this one has all the rows as well. And let's just do a quick trace back during the working. So 1.1 and numeric, so it goes quicker. Also doesn't resolve. Yeah, and so you see it works perfectly fine. And that's it for the lab section. Mostly recall questions, but let's go ahead. What was ISIS originally designed to route? IPv4, IPv6, CLNP, and Ethernet. Again, as I mentioned before, this is mostly a recall question. The answer is C. Question 2. What's the correct format of a net address? The answer is B. Of course, we just did that in the lab. Which ISIS level connects multiple areas together? If you remember again from the lab, there is no level 0, level 1 doesn't do that, only level 2. What makes ISIS easily extensible? LSAs are for OSPF, subnet doesn't make sense, nor does VRF. The only answer is, of course, TLVs. If you want to remember everything, I made some Anki flashcards as well for this video, and also check the description for the lab that we completed previously.